Okay, good morning. Today I'm going to go through two vaguely similar questions from SMO Senior Round 1. The first one is Q24 from 2021 and the second one is Q20 from 2022. Okay, so the first question asks us to find the smallest possible value of n such that 2021 n over 2021 plus n is also a positive integer. So the first thing we need to do is, since we basically are trying to figure out when does 2021 plus n divide 2021 n, we're kind of interested in the common factors between the two, the numerator and the denominator. So to check all the cases, we first consider the case of n being co-prime to 2021. So if n is co-prime to 2021, then we have 2021 plus n is co-prime to 2021n. So it dies instantly, it's not an integer. So we know n has to be not co-prime to 2021. So since 2021 is 43 times 47, we consider two cases. First of all, n equals to 43k. Okay, so then we have the fraction would be 2021 times 43k over 2021 plus 43k, which dividing both sides by 43, we got 2021k over 47 plus k. So since we're interested in minimizing n, the smallest possible factor to divide into 2021 here. Okay, so first we have to check, do k and 47 plus k have any common factors? So since k 47 is prime, the only possibility for them to have common factors is if k is 47 times some number. But if you set k to be 47 times some number, you'll end up with, let's say k equals 47m. Dividing both sides by 47, you get 2021m over m plus 1, and then m would have to be 42. 42. So in the other case of k and 47 plus k not being co-prime, we have to have 47 plus k dividing 2021, and in that case you basically have to set k equal to 2021 minus 47. And actually in both of these cases you still get the same answer of 42 times 47. So then the other case to consider is n equals 47k. So here we have 21 times 47k over 2021 plus 47k, and dividing both sides by 47, we get 2021k over 43 plus k. And here the difference is 43 plus k can divide into 2021 much easier because we have the factor 47. So we can simply set k equals 4. So minimizing n, we set k equals 4, and we basically have n equals to 4 times 47. So we have these two possible answers, and we just take this one because it's smaller, and we win. It's 188. Yeah. Okay. Okay, so question 20 from 2022 is a similar question, but here instead we're trying to maximize n, where 20n plus 2020 over 3n minus 6 is still an integer. So what we notice here very quickly is that the top and bottom both have like common factors, as in like you can factorize out 20 and 3. So you basically have 20 over 3 times n plus 101 over n minus 2. And we can basically replace n minus 2 with m, because all we care about is the difference between the numerator and the denominator. So say setting m equals n minus 2, we get this, m plus 103 over m. So here what we're trying to figure out is whether the product of these two fractions is an integer. So here we can consider two different cases. Similar to the last question, we basically consider whether the fraction has common factors. So the first case is m is co-prime to m is co-prime to 103. Then we would have m plus 103 and m would like not share any common factors. So what you can do is you can rewrite the fraction as 20 over m times m plus 103 over 3. And yeah, here what you can do is, since m plus 103 and m are co-prime, and since 20 and 3 are co-prime, all you need to do is find m such that both of these fractions are integers. And looking at the fraction on the left, the largest m where 20 over m is an integer is m equals 20. And miraculously, it works on the right side because 123 over 3 is 41. So you basically set m equals to 20, and we have n equals to m plus 2 equals to 22. On the other hand, we can consider the case that m is not co-prime to 103. So since 103 is prime, we basically just set m equals to 103k, and then we have this fraction would become 20 over 3 103k plus 103 over 103k, which is equal to 20 over 3k plus 1 over k. So again, since k plus 1 and k are co-prime, you can just replace this with 20 over k times k plus 1 over 3. And again, here what you can do is they both have to be integers, so you look at the one on the left and set, oh, k equals 20 is the maximum number, so that 20 over k is an integer, and it works on the right side because 21 over 3 is 7. So you set k equals 20, and hence m equals to 2060 because 103 times k, and then n equals to m plus 2, so it becomes 2062. And comparing these two possible answers, this is bigger, so we win. N is 2062. So, like, in general, these questions, all you have to do is just, like, with the limited time, just, like, case bash. You basically just case bash, like, you prime factorize the big numbers, and then you case bash to check whether all the integers are co-prime with it. And that's pretty much all.